Good afternoon, ladies and gentlemen. Welcome to Grant Funding and Monitoring and Verification Technologies for Energy Savings. This webinar today is put on by Fair Grant Writing and Green Management Group. Our presenters today are going to be, first off, Graham Fowler. He's the president of Green Management Group, and he will be followed by Igor Shigrin, principal of Fair Grant Writing. And without any further ado, I'm going to hand it off to Graham.
Good afternoon. I'm Graham Fowler, and I, as Colin had said, with Green Management, and I'm going to talk primarily about monitoring and verification with respect to energy conservation. So perhaps the most important slide in this presentation is what you see here. And monitoring and verification is really just making consumption and performance visible. As I said, we're just going to focus on energy today to a large extent. And I would like to show you that previously in a fryer ventilation of a quick service restaurant, the red line represents the amount of energy consumption that had traditionally been there, and it would use over this period of time, which is the y-axis, close to 12 kilowatt hours per day of energy. Converting the motor on the fan to three-phase electrical saves a considerable amount of money and energy, which is viewed by the blue line, the squiggly line. And then when you add monitoring and verification, you get the automated control of that motor, and it goes up and down depending on the activity that's going on the cooking surfaces below it. What does that mean? Well, in a 5-year program based on an average typical US cost of energy, it's going to save the proprietor close to $3,000. Now, the expression that a dollar saved is a dollar earned is nonsense in business, because in an operation that uses a lot of energy and has very small margins, we see that $3,000 savings over 5 years is the equivalent of $42,500, which is about a 14 or 15 to 1 ratio. We use these types of devices to basically audit and predict what type of savings we can offer a client. And we use various different associations to try and standardize the information. In this case, it's the IPMVP, which is the International Performance Measurement and Verification Protocol. In many ways, a monitor is nothing more than a sensor with some sort of output. It can vary from a crude mechanical device to something that's connected to an application program interface that can be pretty sophisticated and be used as input for AI applications, artificial intelligence. So automation and automation intelligence is basically just a sophisticated version of what we've been doing since the dawn of civilization. You know, originally it was people People would go out and look at things, report to a superior who would make a report, who would, and it would go up the chain. And ultimately, some leaders would make a decision based on that information. So when it comes to an audit, an energy audit, we look at different inputs and how much load they have with respect to time, which is just another way of plotting energy consumption. And in this graph, which is a typical graph, you have two particular things that we're monitoring. And the blue line represents the addition of some sophisticated or not so sophisticated monitoring and verification equipment, which will automatically control these devices. And what you see above the blue line is what we would call wasted energy, or the energy that you're paying for that is unnecessarily draining your pocketbook. Bear with me while I just update. So this is a borrowed, well, actually it's my modified illustration. On the left, you'll see that there's an electrical panel. It could be a gas input monitoring device. And we see electricity, natural gas, water, temperature, occupancy. So these are all sensors that are connected to a wireless data hub and transmitting consumption over time. Now you can monitor just about anything that's physical. And the wireless data hub is then generally connected to a cloud, which has an API, an application program interface. So above the cloud, you'll see your application platform. That's just where you program how you want to manipulate the information or store the information or whatever. And below the cloud, you see data mining, and that's just the output from your API. That generally is going to be driving a monitor which is visualizing your energy consumption. But even something like water can be looked at as energy. For example, if you're running a nuclear reactor, you're basically injecting water into a very hot environment, which is instantaneously creating steam, not much different than the gas being atomized to go in the cylinder of your automobile. Now, the outputs can also be, as you see here, an SMS alert that's sent to your phone telling you that some piece of equipment or some system has reached a threshold, a critical threshold, and before it shuts itself down, you might want to get a service technician in to look at the situation. And then the last panel is basically a classic example of the information that you would have produced with a program that's connected to the cloud data stream or historical data stream. So I'm going to just jump aside here from a point of view of historical business paradigms. Between 1900 and 1960, it was a sort of mechanical age and things just got bigger and faster, but they remained dumb. So we go from, and this is reflection of big business. 1930 70s, we started regulatory compliances, which went to strategic environmentalism, which led to sustainability. And the next step is net zero, net minus. Net minus being some sort of closed system where you're actually taking carbon out of the air as one of the byproducts and putting it into something that can be used, such as fertilizer or whatever. So a classic example would be a proposed system to make graphene, which is a very important component in nano particle manufacturing. And somebody's figured out how to do this and end up with solid carbon particles that can be used as fertilizer. The value of our businesses, of course, is continually evolving. And here again, this represents big business. Prior to 1975, you were in a situation where the physical assets, inventory, machinery on the floor, etc., input, inventory, production were really what measured the value of your company. The intangibles such as brand value, advertising success, marketing capability, the value of your team, your employees, are becoming more and more valuable as we recognize that most simple things that are manufactured can be done by a host of different people and different companies. This is very evident in the multiple tiers in large industries like the automotive industry. Canadians tend to be far more comfortable accepting smaller margins with less risk and being a tier 2 supplier to the automotive industry and maybe specializing in stampings rather than trying to market and sell and assemble an automobile. The more sophisticated business become, the more important M&V. So this is outside of the environmental directly anyways. It's indirectly associated with the environment as car manufacturers try and make their cars less and less polluting. This is an example of a device that has multiple monitors or sensors, but very dumb outputs. And of course, that's by design because the manufacturer wants you to take the automobile back to your dealer, and doesn't want any independent garage having access to exactly what the problem is. So this is an example of an occupancy monitor coupled to LED sensor, and it's driving a lighting system in 3 different rooms. So the red area represents a room, and these rooms are all about the same size and the same application. They're training rooms, where fluorescent lighting is manually turned on and off, and it's typically turned on at the beginning of the day, and it runs flat out until the end of the day when it's turned off. The energy consumption is that area under the red area, and the cost of running it is some mathematical proportion of the area. You can see the blue room automatically, there's no manual light switch, automatically starts to turn on the lights It's driven by a sensor or a monitor that recognizes when there's motion or heat in that particular area. So it doesn't necessarily have to turn all the lights on full boogie. It can run lights that are within certain designated areas of the room. And you can see that it fairly rapidly comes up to full power. And then at lunchtime, most of the people leave the room and the lights partially dim. And then in the afternoon session, it picks up again. So the energy consumed and the cost to operate it is the area under the blue chart. The green represents a similar room run with a similar type of LED sensor driven technology. As you can see, there are considerable savings to be had. And it's reminiscent of when the Japanese got into the automotive manufacturing business and focused on saving a couple of grams here, there, and everywhere. The American car manufacturers laughed, and their policy was, if it's less than 5 pounds, don't bother upgrading it. So we can see if you've got a building with 100 rooms, that you're essentially cutting your lighting demand considerably. Obviously, things like hallways, common areas, restaurant areas, et cetera, tend to stay on all the time. So how can we use this information for other applications besides just directly saving money on energy? Well, this is an example here where you run it through an API, an application program interface, and you look at the historical use either as a load over time or just as energy. And we looking at those same 3 rooms again. And we can see that on Monday at a particular time, the lights essentially came on. And for the purposes of my crude chart, I just made horizontal lines. Obviously, they would be squiggles that go up and down within a narrow band. And then it gets turned off for some period of time at the end of the day, and then it comes on. So, sorry about that. And at that point, you can see the energy consumed over a period of a week. And the same with the green room. But the black room, which is the manual room, you can see that it comes on Monday morning for a period of time. Somebody goes into the room and then turns off the lights. And then somebody goes in on Tuesday and turns off the lights. And then somebody does the same thing on Wednesday and leaves the lights on. In fact, the lights may not even get turned off until 3 or 4 days hence. So it's interesting to see that this is wasted energy. But if you're running a large building or you're running a medium-sized building and you're looking for space because a certain department's getting larger or whatever, you can use this type of information to basically see that the black room has very little occupancy and is probably nothing more than wasted space. So for example, we use this type of application within a regional hospital, which is a fairly large building. And that building had 7 conference rooms, and the conference room in the executive hall or section was used the most, and then there were a couple of other rooms that were used. That were used quite effectively. But 3 of the rooms basically didn't ever have anything going on. And they were departmental meeting rooms. And of course, when administration suggested that they relinquish the space, there were cries of foul play, etc. But when they were presented with the evidence, there wasn't really much they could say. Here's an example of a compressor for an air conditioning unit that was recently serviced in a client's facility. It was actually a convenience store. And this is a record of the compressor's utilization during two similar days or time periods of those days. And you can see on the left that the compressor is never shutting down. So the technician who had serviced it had unfortunately made a mistake. And if you weren't monitoring that piece of equipment, you would be none the wiser and be paying for two things: a lot of excess wasted energy and a repair bill for a worn out compressor in a much shorter period of time. So I'm going to wrap. Sheesh. I'm not very good at this. I apologize. I'm going to wrap this up and just review what a monitor is typically used for. And it's live data collected as a continuous data stream and mapped over time. Often is input to a sensor, e.g. lighting, occupancy, or daylight harvesting. Daylight harvesting is strictly a room that has windows, and when the sun is shining or in a particular part of the sky, there's light coming into the room, and the lights, particularly nearest to the windows, do not need to be turned on or can be dimmed. And it's frequently input these days into application program interfaces for custom report generation, as we saw. It's used for sub-metering of rental space. It's used to reduce the incidence of catastrophic breakdowns. A classic example on a car that you're familiar with is a rev limiter. Once the RPM of the engine gets up to its manufacturer's limit, it shuts it down. And then on the side of certain jurisdictions have different ways of incentivizing large users of electricity to reduce their load during a time when there's exceedingly high demand on the electrical grid. And we call that demand reduction. And you basically, in Ontario, for example, sign up with the authority and get paid to be in a position where they tell you with a 24-hour notification that you are going to be restricted to a preset and agreed to amount of electricity during a specific period of time. And in order to meet that, you really want a reasonably sophisticated M&V system that's going to ensure that your building or processes or combination thereof don't exceed the limit that you've agreed to. It's used also during power failures, not only to alert something like a generator, but generally speaking, the emergency backup, whether it's a battery or whether it's diesel or gas generation, is only going to supply a fraction of the amount of power that you would normally use. So M&V is very effective at monitoring and limiting and controlling your building so that it stays within the limits that you've set. And once again, there's just an infinite list of input and output things to monitor. Gas, water, special sauce being whatever you manufacture that's a liquid, consumption. It goes on and on and on. Verification. Well, if we were to take something like monitoring and verification, it's really a slang term because, something like a baby monitor is really not a monitor. It's just a broadcast device that allows the parent to actually monitor what's going on. So verification is a bit nebulous, but generally it refers to compliance. So if you're running a restaurant or you're in the food industry or food transportation industry, you have to comply by producing records that your refrigeration of a valuable asset has always been safe. And so compliance is important. We covered demand reduction earlier. Verification is used for energy audits. It's used for device or system performance. And it's also used for things like occupancy. API connected functionality, which is really, the processing of the data, is used to issue SMS alerts. It's used as input for the Internet of Things, integrating data and applied analytics. So the Internet of Things may have a host of other pieces of information that are very valuable in terms of determining how something performs. For example, outdoor air temperature, humidity, time of day, et cetera, et cetera. Building security. So rather than having a guard monitoring 10 different video panels, it's a much more effective way to put sensors, lighting sensors that monitor motion and infrared heat. And basically when they detect some intrusion, they turn on the lights and turn on the camera and turn on a recording device. This can be used for pest control in the grocery, food industry, because little pests like rats run around and trip the building security. So if you see that your lights came on during the night and were recorded by the security cameras, if it's not an intruder, a human intruder, that you probably got a pest problem. And then intelligent maintenance, not scheduled maintenance. So most devices, whether they're in the transportation sector or the manufacturing sector, or even a building's physical plant, all the devices and systems have scheduled maintenance, which is, of course, not very helpful. I mean, it's a good policy, but you're generally replacing filters and bearings and what have you, or greasing things when it's not the ideal time. It's either you're doing it before it's really necessary, or you're doing it way after it was necessary. With monitors or sensors, you can measure so many different inputs that will tell you For example, when a filter needs to be changed or a bearing needs to be lubricated, etc. And then, of course, there's standby power control, which we've already covered. And that basically wraps up my presentation. I would like to say that in most light industry applications, clients are interested in what's really going to save them the biggest amount of energy and money, and those are usually SCADA devices. But in commercial buildings and buildings that are smaller operations, smaller businesses, generally the application of M&V will save up to 20 or 30% of your energy consumption. Again, depending on how sophisticated your industry is and a host of other issues. Thank you for the opportunity to present this to you.
Okay, thank you very much, Graham. That was rather fascinating. And just a couple of sentences of housekeeping, just a reminder, please put your questions and comments in the chat or in the Q&A panel, and we will get to them in the Q&A section. And without further ado, I will invite Igor to take over.
Thank you, Graham, and thank you, Colin. It's definitely fascinating, how far we went, how far we went, from wasting energy unnecessarily to all those fantastic tools that will help us to save energy, which is definitely a good thing. In my part, I'm going to cover the government grants that are available to introduce one of those technologies that Graham just showcased. We will also talk about funding government incentives for saving energy. Just a couple of words about Fair Grant Writing, who we are. We're on a mission to help Asian family and independent businesses survive and thrive by unlocking their access to the government money. And our values and strategic approach to the business funding needs of our clients, coupled with a deep expertise in business and technical writing. A couple of cases that we feature is our aerospace client got $3 million in an interest-free loan from the federal government, and another client got over $300,000 in government grants, non-repayable grants, to upgrade their metal fabrication shop in Kitchener, Ontario. And this one is not our client, unfortunately, but just a case of a particular company in Manitoba that managed to secure close to $100 million in government funding. Of course, not every company would qualify for that much, but if you are ambitious enough and if you have case, then there's pretty much no limit as far as the government funding is concerned. Now let's go a little bit deep into the specific programs that you can use to help you implement M&V technology at your company. And first and foremost is the Canada Job Grant, the grant that is available across Canada, and it pays for the training component. So every technology implementation has the training component into it. So the Canada Job Grant actually does cover that component. A third party who is giving you training in, say, energy efficiency or energy use or energy savings. So all those subjects will qualify, and you can get between 50 and 100% of the expenses. Most companies, though, they get 83% of the training expenses. But this could be a significant benefit for you and definitely an incentive for you to adopt one of the M&V systems. In terms of the software and hardware itself, because that's also a part of M&V technology, I have a good news that I'm happy to announce. So we will have a program for helping to buy technology solutions and adopt technology solutions. The program is called Canada Digital Adoption Program. Now, intake is not open yet, unfortunately. The program was announced in the federal budget, Currently, federal budget is in the process of approval in Ottawa, and as soon as it is officially approved by all kind of levels of parliament, only then this program will become a reality. However, we know something already about the program, that it will be a combination of grants and loans, and the grants will be for technology assessment and selection, and interest-free loans will be here to acquire technology. So in other words, you will be able to get a grant to figure out which M&V solution is the right for you on the market. And then you will be able to apply for an interest-free loan to actually purchase, purchase the technology, install the technology and implement it. Okay. We will know more a little bit later, hopefully through the summer, but worst case in September when the parliament is back. Now, across Canada, there are also many programs that can help you with purchasing software and hardware. And one of the examples is here in Prince Edward Island called IT Implementation Assistance. It's a grant that provides 40% of the project cost, and the project cost includes the hardware and software expenses, but it also includes things like computer, all kind of equipment necessary to buy in order for the project to function, the project management fees, and so on and so forth. So it's not just hardware, software piece and training. It's a bit more than that. Newfoundland has also a similar program, provides 75% of the similar expenses up to a maximum of 100,000. Once in a while, this type of programs pop up in Ontario, Quebec, BC, Alberta, and pretty much everywhere else. But it's just right now we don't have any specific grant for buying software in Ontario. And in Quebec, the grant for buying software is somewhat limited to ERP systems. So there's a great focus in Quebec on ERP versus M&V. Right, so that's just a reality that we're living in. Now let's talk about energy savings incentives. So those incentives are primarily provided through SaveOnEnergy program that is available here in Ontario. And this program has 4 streams, 4 components. And the first stream that's not active just yet, process and system upgrade program. This is for large energy users to basically upgrade their systems and equipment in order to save energy. We expect this program to be available in 2022, and this is when we will know exactly what this program includes. Energy performance program is basically an incentive for you to save, to do whatever you can to save energy. And when you achieve your energy savings goals, the utility will provide you with like a pretty much discount or refund of your energy expenses at 4 cents per kilowatt. Energy Manager program is a program that helps you subsidize hiring a person who will be a dedicated energy manager. Well, we understand that most of the participants are small to medium-sized businesses, so you probably wouldn't have a need to hire a dedicated person for that. But if you have a right size and a right need, then this program is available, and definitely you can take advantage of it. The intake will be in the fall of this year, so stay alert, stay tuned. And last but not least, retrofit program. This is the program that provides you kind of dollars against purchasing or certain equipment that saves energy. It's not just any equipment. There's a list of specific kind of types of equipment that you can buy, and that program can subsidize. Some of them are here on the screen, but there are other categories, and every single category has a list of maybe 2, 3, 4, sometimes 6 different items of different types of equipment that is eligible for the program. I put a link on all incentives in the presentation, so you'll get a copy of the presentation, and you'll be able to click the link and look up the specific incentives. What I can also add is that although this program, particular program, is only in Ontario, other provinces also have similar concepts and similar programs. If you are outside Ontario, just reach out to us after the webinar, and we can find and send you a similar link with the list of programs and incentives in your province. And to conclude, to highlight some other categories and purposes that the government is funding. The government doesn't give the money just because your business exists. It's not enough. Even if your business meets eligibility criteria, is also not the reason to get the government grant. You only get the government grant when you have a project in one of those areas, and those areas typically are equipment purchasing, skills training, hiring, export development and marketing, technology and software, that's what we discussed, research and development, and business expansion. So in other words, the government doesn't provide any operational funding. The government is looking for something kind of out of the box, out of your normal course of operation. And the government is interested in if you look at the grants from the government perspective, it's the investment in your company, although they don't take ownership. They invest the money, and they don't ask for it they don't ask you for a payback, but they expect your business to grow. They expect your business to hire more people, become more productive, sell more outside Canada, and in the end, they will collect more in taxes. So that's how it works, and that's why they don't really give you money for any operational needs. And that concludes my portion of the presentation. There are more grants, government grants, loans, and tax credits out there. I encourage you to fill out the eligibility check form that is located at fjwinc.ca/eligibility. It's a free form that we have on our website. You put your data in there, and then within 1 or 2 days, we'll get back to you with a short list of government grants that are specific to your business, your location, and most importantly, specific to your cases. And on that note, I will pass the torch back to Colin, and let's see if we have any questions.
Okay, thank you, Igor. That was also pretty informative. I just need to do a little bit of housekeeping here. Okay, so right now we have gotten into the question and answer period, and we do have a question coming immediately from David. Graham, this one is for you. Graham, how do you see the switch from energy saving costs that includes electricity bills to now being asked to reduce GHG from fossil fuels, that's greenhouse gases from fossil fuels, as that will have rising costs within the new carbon tax added, with the new carbon tax added? The question is in your Q&A panel, Graham. Graham, you're still muted, we can't hear you. Bottom left of your screen.
Thank you.
You're on.
You hear me now?
Yes, you're on.
Yeah, I think the person who posed the question answered the question to some extent. The carbon tax is right now directly linked to those people who are running forests and not cutting them down, or there's a carbon tax that's directly linked to fossil fuels, natural gas, diesel. They have not been linked to electricity as I know it, but they surely will be. And that will depend on how you generate electricity. Obviously, if Quebec has tremendous hydro reserves, that is seen as renewable energy. Nuclear power is green depending on your perspective or your vision. And if you're producing electricity with natural gas peaker power plants, which Ontario has, they're not much better than producing electricity with coal. So I expect that the carbon tax is applicable to them just as it is to anybody else using natural gas. If you look at the billing on natural gas invoices, you will see that you're paying some percentage for carbon tax. So yes, that's one of the methods that the government is using. The carrot and the stick, that's the stick end of it. The carrot end is the grants that Igor referred to. Obviously, as well as saving energy, which is what I was talking about. Does that answer your question?
David, you could just drop a note in the chat to respond to Graham's thought there. But Igor, as I listen to both yours and David's presentations, I recognize that some of the funding, SaveOnEnergy, does permit for the hiring of energy managers to do a lot in this. But I'm wondering, when we're looking at rolling out the necessary changes to fully implement a whole new energy regime, is there any scope within other grant programs, for example, COJG, to do to cover some of the costs of training people in energy management?
Absolutely. The good thing about Canada Job Grant and similar programs across Canada is that the government doesn't dictate what kind of training you should take and who should take the training. In other words, it's your choice as the business. If your employees need to be trained in energy efficiency, then that's your choice. As long as you qualify for the program, there's no reason why the government would reject it. In the same sense, if as an employer, as owner of the company, you feel that you need to kind of get some more training in the use of MNV technology, maybe you even need to improve computer literacy skills of your employees. Those types of trainings also qualify.
I had a question for Igor.
Please.
One looks at MNV connected to, let's say, a server and API programming. Let's say you do it all in-house. You buy off-the-shelf equipment, you install it, you program it, and you have to train people. Is it not the same as, basically what you're doing is you're improving your operations productivity? Does the government look at that as, say, buying a new CNM machine for a manufacturer that's putting in a piece of equipment on a manufacturing line?
Well, right now they don't look at it this way. They do look, however, to it as purchasing a software, and then any software grant that's out there would qualify. But I definitely hear your point about the productivity. So, with the government grants that are always changing, it's a moving target. So the priority that they have right now is the software, right? Tomorrow they may say, okay, no, forget software. Now it's everything for productivity. Right? In this case, it will be another story, but it will be another program.
Okay.
Does it cover leasing software?
A good question. Actually, if it's a software program, one of those software programs that are available now, they, as far as I remember, they are more geared towards purchasing. And for example, leasing and software as a service model, that's another popular question, whether SaaS kind of software will qualify. Right now, unfortunately, the government grants are not designed for this type of for these types of acquisition or implementation. So for now, I'd say the best way is to still buy kind of buy this piece of technology, buy the piece of software versus a SaaS model or versus leasing.
Okay, I have a question for Graham. Chris might find this one fascinating. When we install all of these energy monitoring tools, along with the other push in technology of going the route of IoT, is this something that we need to consider? And I think, Igor, there may be components in this for us as grant application writers. Are we now looking at, with all of this data moving around, are we looking at perhaps needs to improve IT infrastructures? Graham?
Not really. If you run if you run a couple of, if you're a franchisee for, say, McDonald's, for example, they have programs and will force those technology changes on you, and they'll put all the application software in the cloud, and they'll end up owning that information. For independent companies, there are people that we deal with, Best Energy, for example, that have an SAS turnkey application where you end up purchasing the hardware and basically paying a monthly fee to cover the application software and the processing of the information and the storing of the data. That sounds like maybe a cumbersome model for an independent business person, but because the payback is so rapid and because the private sector is prepared, provided you've got a reasonable credit rating, prepared to lease the equipment to you on a cash positive model, it's really a no-brainer. It's a win-win situation. A bigger businesses, rather than putting the API system in the cloud and the data in the cloud, will of course harness that that stream of data and those applications in-house, and will probably write their own custom software for their own purposes.
Okay, thanks, Graham. Chris chimes in. IoT will create a lot of data, but it is actually very little compared to the data getting produced by social media. I think that will tell us a lot about not only that particular topic, but perhaps IT managers might want to look at how they can manage their social media. But Igor, would there be, in terms of some of these expansion in equipment that Graham is talking about, is there scope to get some of this equipment through, or to fund the purchase of some of this equipment through grant financing?
Yes. All software, all the grants that pay for the software, they also pay for hardware such as servers, gadgets, whatever you need to, even the workstations that you need to put across the facility. So no, the hardware cost is typically also eligible.
Okay. Okay, thank you, Igor. Okay, ladies and gentlemen, we are up against our time, 1 o'clock. So I'm going to throw one last opportunity to our audience. If you have any questions, what I'll do is I'll just quickly click on allow to talk so that you don't have to take the time to type it out. So if you have any last question, we can accommodate it here.
Just want to add, this is David. There's a new Class 43 acceleration, Igor. I saw a presentation on that, and also conservation fund that sort of fits into what we discussed. Thanks. I'll send it to you.
Yeah.
Okay, thank you.
You can also share it with the attendees.
All right. Any last words? Going once? Igor, Graham?
This is Chris.
Yeah,
go ahead.
Go ahead.
I was just going to say, this is Chris. We're still kind of in startup mode. So if there are companies looking to, significantly reduce their data center kind of power, we can help with that. But we're probably not eligible for a lot of the grants that are ongoing.
Okay. Perhaps we could have a conversation, Chris, about other ways that there might be opportunities for us to work together. But I'll reach out to you about that one. All right. So Igor, Graham, any last words?
Well, I was interested by the comment of the amount of data going up on social media versus IoT. One has to keep in mind that IoT is just getting going, and that IoT is running data streams 24/7. So the volume of data will be astronomical.
Okay.
Happy to show it. I can share those numbers with you.
I'll just add, they showed that a blockchain calculation or a Bitcoin is very energy intensive due to the regulations of monitoring it across every network.
Right. Okay, Igor, any last thoughts?
No, I think had a pretty good conversation today. Just reiterating that if you wanted to check what grants are out there, fill out the eligibility check form, and we'll get back to you.
Okay. All right. Ladies and gentlemen, our audience, thank you so very much for joining us this afternoon. I think we've had a couple of very interesting presentations and a rather interesting discussion. I'd like to take the opportunity to thank Graham Fowler, President of Green Management Group, and Igor Chigrin, Principal of Fair Grant Writing. It has been a stimulating afternoon of presentations and discussion. Thank you all very much. Have a wonderful day.